All right, hello again. I've got a set of slides here to cover for Standard 2 in Calculus. We'll go ahead and get started. Standard 2 focuses on the limit definition of what's called the derivative and how we can interpret it. So in our previous standard, we talked about instantaneous rates of change and average rates of change. The average rate of change is the rate of change between 2 points, and the instantaneous rate of change is the rate of change at one particular moment in time. We'll use that moving forward here in Standard 2 to talk about how the limit definition of a derivative is derived. So first off, we're going to call a secant line and a tangent line. A secant line is a line that intersects a graph at two distinct points. The slope of that secant line, change in y over change in x, represents the average rate of change over the interval between those 2 points. So here in this GeoGebra applet, I have kind of a picture of what we're talking about. So I have a curve with a red secant line intersecting the curve twice at points P and A. What would the slope of that line be? Now, I don't want to find the actual slope in this case, at least not right now. I want to use expressions for that. So the vertical length and horizontal lengths are shown using this triangle. For our distance h from point x, adding on point h, this would be this would be point x plus h. The vertical length would be the difference between the outputs at f of x and at point f of x plus h. Let me draw that same one here just to give you a little bit more understanding of what I'm talking about. So we have a curve with 2 points. And we're going to draw the secant line through those 2 points. This would be point x. I add on some horizontal distance till I get to the second point, which would be x plus h. So as a coordinate, the first point would be x comma f of x. The second point would be x plus h comma f of x plus h. Now for our slope, we're talking about change in y over change in x. So what's the total difference? What's the total distance horizontally and vertically? Well, the total distance horizontally would just be this h. How far is it from point x to point x plus h? That would be a horizontal distance of h. X plus h minus x. The vertical distance will be the difference between those two outputs, the two y coordinates, f of x plus h and f of x. So the average rate of change, the average slope between those 2 points would be the change in y divided by the change in x. So the slope, we'll call that, would be f of x plus h minus f of x divided by h. This is the average rate of change. The slope of this line is not the same as the slope of the graph at this point, or the same as the slope of the graph at this particular point. It's the average slope of all the points within the interval. Right? We're a little bit flatter down here. We're a little bit steeper up here. Overall, within the interval, the slope of this line represents the average rate of change, the average slope of all the points between the two we've outlined. All right, so what happens if I let h go to 0? If I let the horizontal distance between those 2 points decrease? That secant line would then turn into a tangent line. Let's see that in action. If I let h decrease, the 2 distinct points are getting closer and closer together until eventually they overlap at 1 point. The slope of that secant line would now be the same as the slope of the tangent line at that 1 point. We've taken our average rate of change between 2 points and developed what's called the instantaneous rate of change at one particular point. Now, I've got this kind of written as the expressions, but if I look at the actual slopes for this particular graph, notice how the slopes of the secant line and the slopes of the tangent line come together. Except when h is 0, there is no slope of the secant line. Now, why would that be? If h is 0, there is no horizontal difference between the 2 points. I'm dividing by 0 and therefore undefined. So what we work with is what's called a limit. A limit as h goes to 0 of f of x plus h minus f of x divided by h. How does our slope behave as h gets infinitesimally closer and closer and closer to 0? Once again, I can't just substitute h equals 0 into my difference quotient here because I would be dividing by 0. I'm going to let h get so close to 0 that it's essentially the same thing. This is what's called the derivative, or instantaneous rate of change. We've taken what we know about the slope between 2 points, let those 2 points come together. Now I have the slope at only 1 point by letting h get closer and closer and closer to 0. So like we said here, what happens is h goes to 0. Well, the 2 points come together. Rather than having a secant line, we've created what's called a tangent line, where we only intersect the curve once. The slope of that tangent line also represents the rate of change at that one particular point on the graph, called the point of tangency. So secant line versus tangent line. Secant lines intersect twice, tangent lines intersect once. We can find the slope between 2 points and let those 2 points come closer and closer and closer together using a limit as h goes to 0 to find the slope of our tangent line, therefore the instantaneous rate of change in the function at our point of tangency. In this case, point P. So let's talk a little bit more about the derivative. The derivative of some function f of x is given as f prime of x, kind of this symbol right here. That is another function that gives the slope of the graph, the instantaneous rate of change, at any point x equals some constant c. So I'll outline them down below. F prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. This should be a little bit familiar to us. This part of that formula represents the rate of change between 2 points, the average rate of change. As I let the limit of h goes to 0, I turn that average rate of change secant line into an instantaneous rate of change for the tangent line. This is now known as the derivative, f prime of x. There's lots of different notations for the derivative. The ones that we typically see would be f prime of x, y prime, dy dx, d dx of function f of x. You'll see all those. Those are all synonymous. They mean the derivative of some function. All right, so our big idea here, to kind of put all those last big concepts together. The slope of the tangent line, or instantaneous rate of change at a particular point, is known as the value of the derivative at that point. So let's put that into practice. I want to find the derivative function for f of x equals x squared, and then use it to find the slope of the tangent line, the slope of the graph, the instantaneous rate of change for when x equals 2. All right, so we have f of x equal x squared, and I want to find the derivative. The derivative is given as the limit as h goes to 0 of f of x plus h minus f of x divided by h. All right, so we'll set this up. Our function is f of x equals x squared. So f of x plus h, using function notation, that means to substitute x plus h in for x into our function. So our derivative, f prime of x, equals the limit as h goes to 0 of x plus h squared. Rather than x squared, f of x plus h would be quantity x plus h squared. We substitute x plus h into our function. F of x plus h is given as x plus h quantity squared. Now we need to subtract off f of x. Well, f of x is equal to x squared, all divided by h. All right, so our goal here is to simplify this as much as possible and evaluate the limit. F prime of x equals the limit as h goes to 0. X plus h squared, that would be x plus h times itself another x plus h. And if I distribute that out, I'll get x squared plus 2xh plus h squared. That's what this simplifies to. I get x squared plus xh plus xh plus h squared. We'll keep bringing down minus x squared divided by h. Is there anything so far that we can simplify? Well, x squared and negative x squared should cancel out. Let's keep working here. F prime of x equals the limit as h goes to 0 of 2xh plus h squared divided by h. All right, let's look again. Is there anything else that I can simplify? Notice that these three terms all have a value of h. So I can divide that out. F prime of x equals the limit as h goes to 0 of 2x plus h. I divide an h out, so that h is gone. That h is gone. And h squared, I can cancel out one of the two h's. So what's important going from this step down to the next? Can I substitute in 0 for h in the first line? Can I substitute in 0 for h? No, because I'd be dividing by h right here. Can I substitute in 0 for h here? Well, certainly. That would just be 2x plus 0. I can now use direct substitution to evaluate the limit. And I get 2x. F prime of x is equal to 2x. The derivative is another function that will allow us to find the slope of the graph at any point I want. We want at x equals 2. So what is f prime of 2? Well, that would be 2 times 2 are 4. The slope of the graph at 2 is equal to 4. At precisely x equals 2, at that one moment, at that one point, the slope of our tangent line, the instantaneous rate of change, the slope of the graph, is equal to 4. If I wanted to find the slope of the graph at x equals 0, it would be 2 times 0 or 0. If I wanted to find the slope of the graph at negative 3, it'd be 2 times 3 or negative 6. I'm just plugging in any x value for any point that I want into our derivative to find those slopes of the graph. We can do the same thing for our next example. X squared minus 5x plus 3. I'll find the slope of the graph at the coordinate 1, negative 1. So how do I find the slope of the graph? I need to use the derivative, which we know to be the limit as h goes to 0 of quantity f of x plus h minus f of x all divided by h. All right, so let's get this set up. Keep using green. The limit as h goes to 0. Well, x squared would be x plus h squared. I need to simplify using function notation and write out what f of x plus h is. So for every x, we're going to substitute in x plus h. So next, we're going to have minus 5x or minus 5 times x plus h. Don't forget to bring down the next plus 3. That takes care of this. Now we need to subtract off what f of x is. So we're going to subtract that entire function. Now let's put this in parentheses. Minus x squared minus 5x plus 3. All divided by h. All right, so let's keep simplifying. The limit as h goes to 0 of x plus h squared. This one is good to memorize. X squared plus 2xh plus h squared minus 5 times x plus h, so minus 5x and 5h plus 3. All right, so now I need to bring over, let's see, if I subtract x squared and I subtract negative 5x, that's positive 5x, and I'll subtract 3, so minus x squared plus 5x minus 3. Squeeze that in right there. All divided by h. All right, so I've got some big hairy mess here. Let's keep simplifying. X squareds cancel. Negative 5x, positive 5x cancels. Positive 3 and negative 3 cancels. What I'm left with is the limit as h goes to 0 of 2xh plus h squared minus 5h divided by h. What can I divide out? Well, all of these terms contain an h. Here, 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 and here. So that's going to give me the limit as h goes to 0 of 2x plus h minus 5. I divide it out. This h, this h, this h, and one of those two h's in h squared. So what's important about this step to this? Can I plug in 0 for h in this previous line? No, I can't. I'd be dividing by 0 because I'm dividing by h. Once I cancel that h out, I'm left with this. Can I go for h here? You bet. 2x plus 0 minus 5. So that's going to be 2x plus 0 minus 5, or simply 2x minus 5. F prime of x equals 2x minus 5. So if I want to find the slope of the graph, of f of x equals x squared minus 5x plus 3 at any point I want, I can plug in that point to the derivative. F prime of x equals 2x minus 5. The point we want is 1 comma negative 1. So substitute in 1 for x. F prime of 1 equals 2 times 1 minus 5. It's 2 minus 5, or negative 3. The slope of the tangent line, the slope of the graph at x equals 1 would be negative 3. All right, I think we'll call it there. Have a good one.